So continuing the notes from last time, which was on quadratic functions, we could look at this problem here, where we want to use Desmos so that we can write the equation of g of x using all three forms. So we can pull up Desmos here, and then click on the plus, click on table, and then we can type in all 3 points into our Desmos window. And then we can see that Desmos here has plotted the 3 points there, and we can see and we can believe that there could possibly be a parabola that passes through all 3 points. And they do want us to give them all 3 forms. So first, maybe in box 2, I can type in standard form. Y equals ax squared plus bx plus c. So Desmos is asking me if I want to create sliders. No sliders for now. Instead, recall what we do. Instead of y, we type in y1. Instead of x, we type in x1. And instead of x, you type in x1. And instead of equals, you delete it and you type in a squiggle. And notice that right away we have the parabola, which is this one here. But the cool part is that Desmos here gives you the values of a, b, and c, which can go back in there. That's how we develop standard form. If we want vertex form, okay, so for vertex form, we know that it's y equals a, x minus h squared plus k. We got that from our notes from last time. Do I want sliders? No, not right now. Instead, change y to y1, change x to x1, and instead of equals, put a tilde. There's the parabola, it's back, but now I have the values of h and k, which I can deposit there and there. For intercept form, typing the equation based on the notes, y equals a, x minus p, x minus q. But of course, instead of y, type in y1, instead of x, x1, instead of x, x1, and instead of equals, put a tilde. And yet again, the parabola has returned, but now we have the values of a, p, and q, which you can deposit in there. So the 3 forms are here. Standard in the top, vertex in the middle, intercept in the bottom. Done with this question. And here is a fact that we discussed today in class. We know that for any parabola in the whole wide world, each parabola is going to have what we call a vertex. And the vertex is a point. And every point in 2 dimensions has an x coordinate and it has a y coordinate. And the way that you can find the x coordinate of a vertex is by going negative b over 2a. What's a, what's b? Recall standard form. So if I present to you an equation in standard form, you can take a and b, plug them into this expression, which by the way comes to you from calculus, the additive inverse of b over 2a. If I give you standard form, take ab, plug it in here, boom. This is the x coordinate of the vertex. How can you find the y? Take the x coordinate, whatever number this is, and plug it in for x there and there. And whatever all of that is your y. So let's apply this technique to one problem. This problem right here. So we want to know the height of the bike off of the ground. So because it says how high off the ground, we know that we are interested in the vertex. So let's go negative b over 2a. So the x coordinate is going to be negative, and then b over, and then 2 times the value of a, like that. And if you type this into your calculators, and if you round it to the nearest hundredth, it should be about 4.17. I believe the actual value as a fraction is 25/6, but I'm okay if for now you round. So for that bike, let's just pretend that this is the bike here. We know that the bike is located at the vertex. So that's our vertex where the bicycle is at. And we know that the x coordinate is 4.17. But what about the y coordinate? The y coordinate is the actual height of the bike. So we have to take 4.17 and plug it back into the equation. So that would be something like y equals negative 0.15, 4.17 squared plus 1.25 times 4.17, and then of course plus 20. And if you type all that in, it should be about 22.6. So this is the actual height of the bike, so we can answer the question. So the bike is 22.6 feet above the ground. To find an x-intercept, we set y equal to 0. To find a y-intercept, we set x equal to 0. Yes, so this is how this works. So let's apply this technique to the problem here. So we want to know how far away the cars are from each other. So let's just doodle this real quick, something like that. Here is one car, and here is the other car. I want to know how far away the cars are from each other. So again, this vertex, I don't care about it at all. I want to know where this is, I want to know where this is, and I want to know the separation between them. So I am interested in the x-intercepts. To find x-intercepts, you set y equal to 0. H of x is pretty much the same as y. So we can write down the original problem, but instead of h of x, just pretend that it says y. And once you've done that, recall that to find x-intercepts, you set y equal to 0. So 0 replaces y. So now I have before me a quadratic equation. And one option to solve this quadratic equation is the quadratic formula, this one. So let's apply the quadratic formula, where this is a, this is b, and this is c. And now if I clean up a couple of things, double negative became positive. All of that in a calculator is 1.4. 2 nickels is 1 dime. And now I can square root the 1.4. So now I see that I am about to have two answers, which is good because I have two vehicles. I have two x-intercepts. So now the plus or minus can be broken up into two different setups. So I have the plus case and the minus case. So this first answer should be about 19.8. It's actually exactly equal to that. And this one down here should be about negative 3.8. So these two numbers represent the locations of the vehicles. So this one here was at negative 3.8 comma 0. And this one here was at 19.8 comma 0. So the quadratic formula told us the location of the x-intercepts. I now wish to find the difference between them. So I go the end minus the start. And this has a difference of 23.6, and so we can summarize the question. I think they forgot to mention feet, but it should have been in terms of feet. So the vehicles are 23.6 feet away from each other. In closing, here is the summary. If we are interested in the vertex, boom, we go negative b over 2a. This will be the x coordinate, which you plug back in to find the y. If you are interested in the x-intercepts, we can bust out the quadratic formula to find these locations. So it is important that we are able to distinguish between the two objectives, between the two formulas, and it's always just good to know what we want. Vertex here, quadratic formula for x-intercepts there.